project, I'm going to be doing chemistry. Specifically, I'm going to be doing endothermic and exothermic reactions. An endothermic reaction takes in energy, while an exothermic reaction releases it. First experiment, I'm going to be using potassium permanganate and glycerin. For my first experiment, which is an exothermic reaction, I'll be adding 5 milliliters of glycerin together with 20 grams of potassium permanganate. The first thing I'm going to do is I'm going to calibrate the scale. So I have this beaker here, and I'm going to put it on. Now, I'm turning on the scale and putting it on tare. Now that it's at 0, I can proceed to putting in the potassium permanganate. Now that I've measured out 20 grams of potassium permanganate, I am going to put in 5 milliliters of glycerin. Now I've measured out the glycerin and the potassium permanganate. We'll be doing the experiment outside because I don't want to get the house all covered in fumes and everything. And the experiment will be conducted in this bowl. First, for my experiment, I'm going to dump in the potassium permanganate. And now I'm going to add the glycerin. The reaction won't happen right away, but it will happen soon after. We'll observe and see what happens with potassium permanganate and glycerin. As you can see, the reaction released so much energy and it was so hot that it even broke the reaction vessel. For my endothermic reaction, I'm going to be using barium hydroxide and ammonium chloride. I'm going to measure energy by using a calorimeter. So what I'm going to do is I'm going to fill this part up with water. Then, in this beaker, I'm going to add ammonium chloride and barium hydroxide. Then, I'm going to put the beaker into the water. The reaction will happen there, and I will use this thermometer to measure the reaction change. I've carefully measured out 65 milliliters of water. Now, I'm going to pour it into the calorimeter. I'm going to measure out 5 grams of ammonium chloride. I've measured out 5 grams of ammonium chloride and 16 grams of barium hydroxide. So I'm going to add the ammonium chloride to the barium hydroxide. Now I'm going to stir it together. Right now the temperature of the water in the calorimeter is 50 degrees. I'm going to put the beaker into the water and measure the temperature after the reaction occurs. So as you can see, it has turned into a liquid. And so it smells really bad, just for you to know. So, yeah. The ending temperature result was 35 degrees. It went from 50 degrees at the start to 35 at the finish. That means that it sucked out 15 degrees of energy out of the water. I measured out 5 grams of ammonium chloride and 16 grams of barium hydroxide. Those mixed together took so there was 65 milliliters of water, and out of that water there was a 15-degree temperature change. As you can see, the barium hydroxide and ammonium chloride have turned into a liquidy substance instead of a powder, and that's a pretty big change.